Welcome to this simple demo of Multiloop 3. In this video, we'll create a conductor and survey geometry. The first step is to import a mesh. I have clicked on the Multiloop icon to get an empty project. Now I'll import a mesh. Here I am inserting a Pebble MCL file. The meshes are in Files, and here I will pick a file. Here the file is being picked, and I will get the Insert Assembly dialog. The Insert Assembly dialog summarizes the extent of the mesh in X, Y, and Z, as shown here. You can also scale the mesh. Here the mesh will be made bigger by a factor of 50, and it will be set at a depth of Z equals minus 100 meters. Here the mesh has been successfully imported. The squares indicate the locations of the mesh node. Here we move the mesh and create a traverse line. So again, here's a view of our mesh. We now click on the assembly menu item and select Displace. This gives the Displace Assembly dialog. Remove the dialog to make the mesh more convenient to look at. We're now going to rotate the mesh around the Z-axis. We hit Apply, and the mesh rotates. We then reset our displacements and rotate around the Y-axis. This will make the mesh vertical. Hit Apply, and reset our action. We're now going to duplicate the mesh by 800 meters. So we type in an offset of 800. And we select Copy. You now see two meshes in the Select Assembly dialog on the left-hand side. Notice that when we select the different assemblies, the assembly that we select is colored. We can now move the selected assembly 200 meters. And we're happy with that, so we're going to say OK. And now let's make a traverse line. So we're going to select Plot Traverse Line. Here's a traverse line dialog. We'll create a traverse line dialog, and we have to fill in the X, Y, and Z coordinates of the start and end points of the traverse line. Our traverse line is 1,000 meters long. So we're going to select the number of stations, so that will be a nice interval per station. We then select medium basis function resolution to calculate the scattered fields, and select OK. Let's take a look at our work. The dark line indicates the location of the traverse line, and we can use the manipulators on the left-hand side to move ourselves about in the 3D space. The traverse line looks a bit short, so let's go back and change it. So we're going to change the start point. Again, let's change the number of stations so we can keep our station interval nice. And then we hit OK. And here's our new traverse line. In the next part, we're going to add a loop. Okay. To add a loop, go to System and select Loops. We're going to create a loop from scratch. Go and edit the vertices. Click Edit Vertices. Here's the Vertex Edit dialog. The boxes on the bottom are the edit boxes for the X, Y, and Z, or North, East, and Z coordinates. Here the coordinates are being entered for the first vertex, and now for the second vertex. And for the third vertex. The coordinates should be entered such that the loop is counterclockwise when looked at from the top. The loop vertices have been created now. Click OK. Loop is loop 0. Click OK. And there's the loop. We can now look at the work by rotating the manipulator using the mouse. We can also use the hand to pan the view. The magnifying glass lets us zoom in and zoom out. To zoom out, click the Option key while pressing the mouse. This gives a 3D view, and we can set the focal point by selecting an object. Click OK when you're done, and we can now zoom out and see the full view again. If you ever get lost, click the space bar. Here we're going to define the transmitter and receiver antennae. To select the antenna, select the System menu option and click on Antenna. Here on the box is a list of the antenna available to the system. For the transmitter, we're going to assign loop 0. We then move the assignment to receiver 1, select the Z pole, dipole. Notice it's X now. We assign and it changes to Z. So the Z dipole is receiver 1, the transmitter is loop 0. Click OK when you're happy with that, and here's our system. We're then going to update the plot of the antenna. First we're going to remove the plot of the loop. And then we're going to replot the antenna. And we zoom in. Notice the loop is easily visible, and we're going to zoom in and look at the antenna that are on the traverse line now. And you can see the antenna now being visible as small red arrows. Now we're going to define the resistivities on the mesh. To select a resistivity function, click Assembly and Resistance. Here we see the two surfaces that are in the model, surface 1 and 2. Selecting the surfaces will highlight the meshes. Here we can change the resistivity by typing in a new resistivity function. We parse the function into reverse Polish notation, and we can then apply a different resistivity to the other mesh, or the other surface of the mesh. Again, parse it into RPN and apply. Higher resistivities are plotted in blue, higher conductivities in red. It is also possible to make a resistivity function with conditional statements. Here the top is resistive, the bottom is conductive. If we're happy with that, we can exit the dialog. It is also possible to go in and edit the resistivity functions once they've been made. Parse it, apply the function, and click OK. The basic model is now set up. In Part 2, system solving and plotting will be covered. For more info, check out the website. Thanks for watching.